Auzubillahiminash-shaytanir-rajeem. Bismillahir-rahmanir-rahim. My name is Aftab Aleem Farooqi. I am Assistant Professor in Biochemistry at Govt Degree Science College, Malir, Karachi. Now today I am starting the lecture for class B.Sc Part 1, subject Biochemistry, and the chapter is continuing carbohydrates and their derivatives, and I have choose the topic which is formation of hemiacetal and hemiketal linkage, and which is a series of lecture number 13. Now students, in the previous lecture stereoisomerism, in which I have explained the different phenomena of isomeric compounds like D and L sugars, capital D and L sugars, small d sugars, enantiomers, alpha and beta anomers, racemic and also the epimers of glucose. So the important characteristic of these all compounds, they are optically active compounds, either rotating the plane chloride in clockwise direction, either in anti-clockwise direction. So here the concept in the topic is racemic mixture is little changed. We have already selected the two isomeric compounds which are rotating the optical activity of light either in clockwise or anti-clockwise direction. But when we will make a solution in which both optically active compounds are mixed in equimolar concentrations, so we will observe the behavior of the optical activity of light in which direction, right? So here this is the concept of racemic mixture. If two isomeric compounds but different optically active compounds are mixed, in which one rotates plane polarized light clockwise while other rotate anti-clockwise and bearing mirror image rotations, each other are optical enantiomers. When their equimolar quantities are mixed, a racemic mixture is obtained which is optically inactive. So here the example of the tartaric acid. Now this is a concept of the tartaric acid. This tartaric compound, tartaric acid, is divided into two equatorial plane in two different half symmetry. This is upper two carbonic compound, this is lower two carbonic compound, the same compound but divided into two half symmetry. So this is the concept of levotartaric. Now the first above position is here, the second carbon atom, the location of the alcoholic group on the left side. This is the levotartaric and expressed in capital D, L tartaric acid. Okay, levotartaric means it will rotate the plane chloride in anti-clockwise direction, and this will because of the presence of arrangement of alcoholic group on the left side, that will term as L tartaric. While in the second type, the location of this neighboring configuration is here, the carbon atom 2 alcoholic group position on the right side. Therefore, this will term as a desrotative because of the rotation of the plane chloride in clockwise direction. This will term and the location of the alcoholic group of the OH group right side, that will term as D-tartaric. While the lower side here is we are observing that location of alcoholic group on the right side OH group, and in this case the lower side or left side of the OH group location. So both are the cases are enantiomers to each other. So here is that the third number one category here, the third number one category is here, which is optically inactive because A and B groups are rotate equally but in opposite direction. Third is optically inactive because of the internal compensation, that is a plane of symmetry can be passed through it. It is called mesocompound. So when we make a such solution in which two optically active compounds either they rotate clockwise or anti-clockwise direction and they have the same chemical properties, when we mix in equimolar concentrations, equimolar quantities, so there will be the optical activity will be net zero. They will be cancelled to each other. The optical activity will cancel to each other. So there will be because of the internal compensation. So isomeric compound optically एक्टिव बट इन इक्वल कंसंट्रेशन। तो यहाँ पर जो कॉन्सेप्ट ये आ रहा है कि इसमें ये इंटरनल कंपनसेशन की वजह से ऑप्टिकली एक्टिव कंपाउंड जो होते हैं दोनों इनएक्टिव हो जाते हैं इक्विवेलेंट कॉन्सेशन की वजह से, और यहाँ पर वो अगर डायरेक्शन ऑफ द ऑप्टिकल एक्टिविटी किसी भी डायरेक्शन में इस कंपाउंड की वाक़या नहीं होती है। तो ये जो कॉन्सेप्ट है ये कहलाता है रेसिमिक मिक्सचर का। नाउ स्टूडेंट, दिस इज द linear representation of carbohydrates in Fisher form. I have described in the previous lectures that we can express the monosaccharides, sugar molecules, into two different expressions, in linear form or in ring structure form. Linear form, linear representation of monosaccharides is proposed by Fisher scientists, which is also called the Fisher representation of monosaccharides, and the ring structure of monosaccharide representation was proposed by Howard scientists. That is why this is called the Howard ring shape structure. So here I am starting the linear representation of carbohydrates, Fisher form. We know that the general formula of carbohydrate is CnH2nOn. Here the formula. So as we will increase the carbon atom from 3 and put it in their carbon number 3, 9, and then same number of carbon atom will be multiplied to this 2, and the same number of carbon atom will be put it in O oxygen position. So the total net formula of the molecule empirical formula will be C3H6 and O3. So here the structure of the new generic compound will be called triose. The 3 carbon atom containing monosaccharide will be called the triose, and the expression of this triose into 2 different monosaccharides examples, like the free reducing sugar group containing aldehyde group, which is also a function group. So and another is the ketone group or carbonyl group, which is a free reducing sugar group. The important point is that location of the first carbon atom is located the CHO aldehyde or free sugar group first carbon atom, while the carbonyl group or ketone group is located at the fixed carbon number 2 position. Now the 3 carbon atom, this C3 1 2 3 and 6 1 2 3 2 5 and 6, okay, and O3 1 2 3. This is the formula, empirical formula of glyceraldehyde. In the same way, here is the another type of the ketose type of sugar, which contains the carbonyl group, which is consists of the same number of carbon atoms C3 H6 2 3 5 and 6, and oxygen molecule is 3. So same number of empirical formula in both the cases of the polyhydric aldehyde ketonic derivative compound, polyhydric and aldehydic and ketonic compound, example glyceraldehyde and dioxyacetone. In the same way, when we will increase the number of carbon atoms, the next one compound will be called the tetroses. And the same way, this is the C4H8 and O4. So here is the position. You can say here you can counting all the number of carbon and hydrogen and oxygen atom. In the same way, this is the compound which is contain 4 carbon atom, and the free reducing sugar group, alcoholic free reducing sugar group or functional group is consists of aldehyde group, which is called the erythrose, while the neighboring is called the erythrulose. The same number of empirical formula, and this is called the erythrulose. In the same way, when we increase the number of carbon atom 5, that will be the empirical formula will be C5H10O5, and the first carbon atom will be located in the aldehyde group. Therefore, the type of sugar will be called the D-ribose, and the neighboring is called the D-ribulose. And their important characteristic is that the location of the carbonyl group is fixed as carbon number 2. Okay, this is called the D-ribulose. Now, this is a 6 carbon atom containing hexose sugar. This is a 6 carbon atom containing hexose sugar. So here this is a simple structure formula of D-glucose, C6H12O6. This is the D-fructose, C6H12O6, C6H12O6. So in both the cases, location of the aldehyde group is here and the carbonyl group is here. So this is and also the 7 carbon atom containing sugar is also heptoses, which example is glucoheptose, and 7 carbon atom containing the ketose sugar is pseudoheptulose. Now students, I am coming towards the formation of hemiacetal linkage, Fisher linear representation. What is the hemiacetal linkage? This linkage is formed in the same compound at different number of carbon atoms. So this linkage is formed in between different number of carbon atoms. So how this hemiacetal linkage is formed. The condensation reaction between aldehyde group and alcoholic group of same compound is called hemiacetal. The condensation reaction of formation of hemiacetal is given as under. So here the structure of the D-glucose. So in the structure of D-glucose, this is the cis-structural OCs, glucose linear chain-based presentation, and the first carbon atom of the carbonyl group of this aldehyde that will react with the 5 carbon atom of the alcoholic group. So here the formation of covalent bond between carbonyl group of first this carbonyl group and between the oxygen of this alcoholic group. Understand this, how this hemiacetal linkage is formed. Hemiacetal linkage is formed in between the carbonyl group of carbon and the 5 carbon atom located alcoholic group of this oxygen. So the next one structure is here. The first carbon atom यहाँ पर हमने शो किया इसको, यहाँ पर जो फॉर्मेशन ऑफ रिंग स्ट्रक्चर हो रही है वो इसके दरम्यान में, ओके। तो यहाँ पर बन रही है हेमिएसिटल लिंकेज। अब उसके बाद इन दिस प्रोसेस ऑफ हेमिएसिटल फॉर्मेशन वन ऑक्सीजन एट कार्बन नंबर 1 एंड हाइड्रोजन फ्रॉम कार्बन नंबर 5 ट्रांसफर्स। यहाँ क्या होता है कि ऑक्सीजन जो होती है कार्बन नंबर 1 से वहाँ से और हाइड्रोजन जो कार्बन नंबर 5 है दोनों यहाँ पर आकर वो हाइड्रोजन जो है वो उसको ऑक्सीजन को रिड्यूस कर देती है। इट मीन्स वी कैन ऑल्सो अगेन से दैट ऑक्सीजन नेगेटिव चार्ज और हाइड्रोजन इज पॉजिटिव चार्ज, सो नेगेटिव अटैक टू द पॉजिटिव चार्ज प्रोटॉन हाइड्रोजन एटम एंड देन रिजल्टेंटली द ऑक्सीजन विल रिड्यूस इन द फॉर्म ऑफ H2O. Therefore, the condensation reaction will be carried out which forms the water molecule and carbon converts into single bond. This here is that the carbon is converted into the single bond. ये जो यहाँ पर है ये क्या है, ये लिंकेज है, ये कोवेलेंट बॉन्ड है, ये जो कार्बन 5 और कार्बन नंबर 1 के दरमियान में बना है। इस तरह से ये चीज़ कहलाती है हेमिएसिटल लिंकेज। Now students, I am starting the formation of hemiketal linkage, Fisher linear representation. So here is the example, the fructose sugar molecule. The condensation reaction between carbonyl group and alcoholic group of same compound is called the hemiketal linkage. Here the structure of the D-fructose, in which the location of the carbonyl group is fixed carbon number 2 and the carbon number 5 alcoholic group that will participate in the formation of the hemiketal linkage. The same concept is here. The carbonyl group carbon will form the oxygen in between these two, the hemiketal linkage formation. तो यहाँ पर क्या होता है कि यहाँ पर जो हाइड्रोजन है ये इस ऑक्सीजन के साथ रिड्यूस हो जाता है और फिर वाटर मॉलिक्यूल फॉर्मेशन होती है रिजल्ट ऑफ द कंडेंसेशन, सेम एज इन आई हैव ऑलरेडी डिस्क्राइब इन हेमिएसिटल लिंकेज फॉर्मेशन। तो यहाँ पर जो है कंडेंसेशन दोबारा होगा और वाटर मॉलिक्यूल रिलीज होगा या डिहाइड्रेट होगा और यहाँ पर 1, 2 और 5 पोजीशन के दरमियान में यहाँ पर हेमिएसिटल लिंकेज फॉर्मेशन होती है। हेमिएसिटल लिंकेज 1 और कार्बन 5 के दरमियान में होती है। तो यहाँ पर जो है ये कॉन्सेप्ट आपकी समझ में आ गया होगा यकीनन। नाउ हियर आई एम स्टार्टिंग the Howard's formula for monosaccharides, Howard's ring shape structure. So earlier was linear shape of structure of monosaccharides and the new one is later on which I am starting, which is called the ring structure formation, which is proposed by Howard's scientists. So these ring structures are of two types. 6-member ring structure is called the pyrene and the 5-member ring structure is called the furane. So, in fact, monosaccharide with 5 or more carbon atoms in the backbone usually occur in aqueous solutions as cyclic rings structures in which the carbonyl group has formed a covalent bond with the oxygen of a hydroxyl group along the chain. So, here the structure, try to understand this structure. This is a linear shape structure. First of all, I am again repeating the hemiacetal linkage in the linear structure formation. This is a positive charge, negative charge. This is the alcoholic group in which the two lone pairs of electron upper side and lower side. So the carbonyl group will attack these lone pairs of oxygen, lone pairs of electrons of oxygen. Therefore, this will form the hemiacetal linkage in between the carbon number 1 and 5. यहाँ पर अभी आप देखेंगे नेक्स्ट वन स्टेप में रिंग स्ट्रक्चर में ये कैसे बनने जाएगा। अब क्या होता है, वही सेम रिएक्शन होता है, यहाँ पर भी कंडेंसेशन रिएक्शन होगा, लाजमी सी बात है। ये हाइड्रोजन जो है दैट विल रिड्यूस टू दिस ऑक्सीजन नेगेटिव चार्ज। सो जो इलेक्ट्रॉन्स और हाइड्रोजन यहाँ पर ऑक्सीजन को रिड्यूस करने के बाद वाटर मॉलिक्यूल फॉर्मेशन करते हैं, जिसकी नतीजे में कंडेंसेशन रिएक्शन होता है और वो डिहाइड्रेट हो जाता है। अब इसके बाद ये जो लीनियर शेप, इसमें आप राइट साइड पर देखें, जितने भी वॉट एवर द नंबर ऑफ हाइड्रोजल ग्रुप्स, अल्कोहलिक ग्रुप्स भी कह सकते कहते हैं इसको, or next the hydrogen atoms which are located on the right side will be located on the outside of the ring in downward position, while the left side location of the alcoholic groups or hydrogen atoms will be in the inside of the ring. So now this is the linear shape structure is going towards the formation of Howard's ring structure. So here the carbon number 1 CHO, okay, this is the carbon number 5, 1 2 3 4 5 and this is 6. This is the sixth one is here. So carbon number 5 of this alcoholic group, again I am repeating here, that will participate in the formation of the covalent bond in between carbon number 1 carbonyl group and the 5 number of oxygen position is here. So that will lone pair of electron will share the carbon atom in the formation of covalent bond, therefore the hemiacetal linkage will be formed and the oxygen will reduce to the oxygen, therefore the water molecule condensation reaction, and this will the oxygen one will be reduced to this hydrogen, therefore the formation of the alcoholic groups. This formation of alcoholic groups from this position here, this position is from here. If the formation of alcoholic groups of this oxygen to this hydrogen, the on the upper side, that will be termed as the beta D glucopyranose. If the location of the formation of alcoholic group on the lower side, that will termed as the alpha D glucopyranose. Now I am explain. I am illustrating here in this structure. Location of this here, the beta alpha D glucopyranose, the linkage, the formation of the alcoholic group at first anomeric carbon atom on the lower side termed as the alpha D glucopyranose, while on the first carbon atom the formation of the alcoholic on the above side that will be termed as the beta D glucopyranose. तो यहाँ पर ये जो चीज़ अगर दोनों दूसरे एंटी पैरेलल होंगे, यहाँ पर समझ आए बीटा डी ग्लूकोपायरानोज रिंग स्ट्रक्चर है। अब यहाँ पर नाउ द रीजन इज हियर, ए वेरी इंपॉर्टेंट रीजन इज हियर आई एम टेलिंग यू, सो दैट व्हाई डज नॉट द हाइड्रोजिल अटैच टू कार्बन 4 रिएक्ट विद द कार्बोनाइल ग्रुप, के बताने का मकसद ये है कि कार्बन नंबर 4 पर मौजूद, यहाँ पर आप देखें स्ट्रक्चर में कि कार्बन नंबर 4 पर मौजूद, देखें 1 2 3 4, ये कार्बन नंबर 4 मौजूद हाइड्रोजिल ग्रुप जो है वो कार्बोनाइल ग्रुप के साथ इसके साथ क्यों नहीं हेमिसेटल लिंकेज फॉर्मेशन करता, क्यों नहीं रिएक्ट करता? ठीक है, वाई डज नॉट द हाइड्रोजिल अटैच टू कार्बन नंबर 4 रिएक्ट विद द कार्बोनाइल ग्रुप, क्यों नहीं करता? जबकि वाइल कार्बन नंबर 5 हाइड्रोजिल ग्रुप रिएक्ट विद द कार्बोनाइल कार्बन, ओके, कि कार्बन नंबर 5 पर मौजूद जो अल्कोहलिक ग्रुप है ये कार्बन नंबर 1 के साथ कार्बोनाइल ग्रुप की कार्बन के साथ रिएक्ट करता है और हेमिसेटल लिंकेज फॉर्मेशन होती है। तो हियर आंसर इज दैट कार्बन नंबर 4 हैविंग हाइड्रोजिल ग्रुप attacking the carbonyl group will lead to the formation of a furane, formation of a 5-membered ring। अब देखिए कार्बन नंबर 4 पर मौजूद जो यहाँ पर अल्कोहलिक ग्रुप है ये हाइड्रोजिल ग्रुप है, अगर ये साथ रिएक्शन करता है, ठीक है, ये इस पर अटैक करता है, ठीक है, इसका जो है हाइड्रोजिल ग्रुप ये 4 नंबर पोजीशन पर मौजूद अल्कोहलिक ग्रुप है, अगर यहाँ पर ये कार्बन नंबर 1 के साथ इस पर अटैक करता है, विल लीड टू द फॉर्मेशन ऑफ ए 5-membered ring, formation of furane ring compound, while the attack carbon number 5 hydroxyl group, while the attack from hydroxyl group located at carbon number 5, ये यहाँ देखें, here is it will locate to the carbon number 1 carbonyl group, will lead the generation of a 6-membered ring pyrene ring structure of glucose. This pyrene ring structure of glucose, which is thermodynamically more stable than a 5-membered ring furane, thus favoring the formation of a 6-membered ring over a 5-membered ring. So here this is the concept is here, okay, why the 4-number hydroxyl group will not attack to the carbon number 1 in the formation of the pyranose ring structure, while the 5-membered ring hydroxyl group will attack to the carbonyl group. So this is the one important reason is here. Now, let's shift our focus to the hemiacetal of glucose Howard's production. If notice, this cyclization process creates a new stereogenic center, carbon 1, which is referred to the anomeric carbon. याद रखें, the carbon number 1 is always an anomeric carbon. Glucose can exist as an alpha or beta isomer depending on whether the alcoholic group attached to the anomeric carbon. Either the alcoholic group is located at carbon number on the right side, that will be termed as the alpha enomer, is the location or is arrangement of alcoholic group on the first carbon atom on the right side, that will be termed as the beta enomer or beta D glucose. Okay, is on the same side as the CH2OH group or is the opposite side. These two forms are referred as anomers of glucose. Both differ to each other in optical activity but identical in chemical properties. Such cyclic forms of sugars are called pyranoses because they resemble the six-membered ring compound pyrene. So this is called the concept of the Howard shape structure in case of the aldose type of sugar. Now, cyclization of fructose to its hemiketal form. Now I am coming towards the Howard shaping structure, how it is from the ketose type of sugar. An example is here fructose. So fructose has a ketone group and 5 hydroxyl group. So fructose should also be able to cyclize to form an intramolecular hemiketal. There are two in fact ways in which a molecule of fructose can cyclize. The first is illustrated below. Here is the structure of the D-fructose. Understand this structure? यहाँ पर देखें आप इसके स्ट्रक्चर को, first, second, third and fourth and fifth and sixth. All this is carbon atom containing. Location of the alcoholic groups and hydrogen atoms on the right side, that will be located in the new formation of the furan ring structure on the right outside of the ring, while the left side location of the groups will be on the inside of the ring. Okay, so now this this is the formation of the furan type of ring structure in between the carbon number 2 carbonyl group and the 5 position. This oxygen negative charge will and low pressure electron will attack the carbonyl group, and the resultant formation of the hemiketal linkage, and resultant in the formation the hydrogen will reduce to this oxygen negative charge, and then 2 water molecule will release as a result of the condensation reaction. Therefore the hemiketal linkage will be formation. Here is the concept is going to be the formation of furan ring structure of fructose. This is a CH2OH, first carbon atom containing CH2OH, second carbonyl group here, second, third is here, and fourth one is here, 5 one is here. ओके, यहाँ पर देखें ये OH, यहाँ पर ये 5 नंबर पोजीशन है, ये और ये दोनों, ठीक है ना, ये इन दोनों के दरम्यान में 2 और ये 5 के दरम्यान में, इन दोनों का जिस 2 नंबर कार्बन एटम, जिस 5 कार्बन एटम कंटेनिंग OH ग्रुप, इन दोनों के दरम्यान में जो है वो फॉर्मेशन ऑफ हमीकेटल लिंकेज फॉर्मेशन होने जा रही होती है, जिस 6 CH2OH. सो हियर द स्ट्रक्चर ऑफ द फॉर्मेशन ऑफ दिस फ्रक्टोज. यहाँ पर क्या होगा, फ्रक्टोज में सिंपल सी बात है, यहाँ पर ये ऑक्सीजन जो है ये इसके साथ अट्रैक्ट करेगी कार्बन ग्रुप के साथ, तो फॉर्मेशन होगी यहाँ पर हमीकेटल लिंकेज की. ये देख रहे हैं आप, ये 2 और ये 2 और ये है 5, ये 2 नंबर, ठीक है, और 4 और 5 नंबर. अब यहाँ पर वही सेम है कि अगर यहाँ पर 2 ऑक्सीजन के मॉलिक्यूल्स हैं एक हाइड्रोजन एटम के, तो जो एक हाइड्रोजन एटम है जो ऑक्सीजन को रिड्यूस कर देता है, तो फॉर्मेशन ऑफ अल्कोहलिक लोअर साइड पोजीशन पर होती है, जिसकी वजह से फिर ये कहलाता है अल्फा डी फ्रक्टोफ्यूरेनोज एंड हेमिकेटल ऑफ डी फ्रक्टोज. दिस इज हाउ प्रोजेक्शन. ओके, नाउ इन द सेकेंड सिनेरियो the alcoholic group attached at 2 carbon 6 attacks the carbonyl group, resulting in a 6-membered ring pyranose form. Here is a different concept. It is not necessary that always fructose sugar will form the furan ring structure. Mostly it is found in 5-membered ring furan form, but in some cases it is also found in the pyrene ring structure form. So this is the concept of the formation of the pyrene ring structure in the concept of fructose carbonyl group containing sugar. Here is some little different case. The carbonyl group, carbon number 2 and carbon number 6 will be involved in the formation of the hemiketal linkage. Here the CH2OH first carbon atom and the 6th carbon atom containing CH2OH, not the 5 position, because the structure is going to be this formation of 6-membered ring pyrene. So the same concept is here. Oxygen will hydroxyl alcoholic group at the carbon number 6 will attack oxygen, particularly the oxygen will attack to the carbon, and the covalent bond formation will be taking place from this at this position. देखें यहाँ पर is the structure में carbon number 2 and this is the carbon number 5 containing hydroxyl group. So here the formation of the hemiketal linkage formation in the next one structure of this case. So the same hemiketal reaction formation, condensation, water molecule will be released. Therefore, the type of the alpha D fructopyranose. What will be the structure will be formed? Alpha D fructopyranose, hemiketal of D fructose. This is a Howard progression. So this is the concept of the hemiacetal and hemiketal linkage formation in Fischer representation and Howard's ring shaped structure representation. So we have I am continuing this topic in the next one lecture. So again you will consult the study for this topic is Western Tour 4th edition Biochemistry. Okay, thanks.